Hey everyone, and welcome back to today's Explainer. Today, we are taking a really exciting deep dive into the actual architecture of algorithmic trading. We're going to explore exactly how you can evolve your MQL5 code, taking it from those fragile, kind of messy procedural scripts and transforming it into a robust, production-grade system using the standard library. So if you're looking to build bots that execute with absolute precision, well, you are definitely in the right place.
Let's kick things off with a quick audit, all right? Have you ever deployed an algorithm that backtested absolutely flawlessly, only to watch it mysteriously crash the second it hits a live market? You really have to ask yourself, do your bots suffer from things like silent handle leaks or maybe critical pointer failures that just completely shut down your terminal while you're sleeping? Look, the market is completely relentless, and waking up at 3 a.m. because an unoptimized script exhausted all your system resources? Yeah, that is a nightmare we all want to avoid. Honestly, it's basically a ticking time bomb.
Okay, let's dive into this. Here is the architectural blueprint for our system today. First, we'll cover the OOP paradigm shift. Then, memory safety and pointers. After that, stateful account and symbol encapsulation. Fourth, bulletproof execution with CTrade. And finally, the CExpert Strategy Framework.
All right, moving right along to Section 1, the OOP paradigm shift, or as I like to call it, leaving the messy workshop behind. So, to build a truly professional architecture, we really have to move past that messy workshop phase. I want you to think of procedural scripting just like that cluttered workshop. You've got spaghetti logic tying everything together, global variables just scattered everywhere, and it makes the whole code base incredibly fragile the second you try to add any new features. Now, compare that to a modular, object-oriented architecture. This is like stepping into a highly efficient, fully automated assembly line. In MQL5, making that transition to OOP means your code suddenly becomes encapsulated, highly reusable, and, most importantly, memory safe. You essentially get to hide all those messy, complex implementation details and only expose exactly what's necessary. It's a total game changer. Which brings us to Section 2, memory safety and pointers, and how you can protect your architecture.
Now, as you probably know, MQL5 is heavily inspired by C++, but it actually handles dynamic memory a little bit differently, mostly just to keep things safe. When you use the new operator to dynamically create an object, MQL5 gives you back an object pointer. But, and this is a big distinction, this isn't some raw vulnerable memory address like you'd find in standard C++. Instead, it's a very safe 8-byte descriptor. And that descriptor references the dynamically created object safely within the MQL5 environment. Getting a solid grasp on this specific abstraction is absolutely crucial if you want to manage your dynamic class objects properly.
So the crucial point here is that you absolutely must protect your architecture from fatal memory errors. Seriously, just one attempt to access an invalid pointer is going to crash your entire program. No way around it. That's why you should always use the check pointer function to validate your objects before you use them. Plus, if you're creating an object dynamically, you have to use the delete operator to release it. If you don't, you are going to hit your MQL_memory use limits really fast. And oh, you definitely need to be aware of handle leaks. Every single open file or dynamic object consumes resources that are tracked by MQL_handles used. Quite frankly, ignoring these red flags is exactly how bots die in production.
But thankfully, the standard library actually provides some amazing tools to help us out here. By utilizing managed collections, specifically base classes like CObject and container classes like CArrayObj, we can actually automate a whole lot of this safe memory management. These containers step in and handle dynamic array resizing and memory release natively, so they effectively shield us from all those manual memory management nightmares you typically face with procedural code. It takes a huge load off your shoulders.
All right, let's look at Section 3. Stateful account and symbol encapsulation, which is all about taming your data.
Now, what's really interesting about this is how it handles the sheer volume of data, because stale pricing is a massive danger. In a standard procedural approach, requesting symbol properties or account data means you are manually calling functions like CSymbolInfo double over and over again. It's clunky, it's slow, and it's super prone to errors. But with OOP encapsulation, we get to use these great stateful objects like CSymbolInfo and CAccountInfo. These objects actually persist their state and handle their own tick updates automatically. That means your core strategy logic is always looking at clean, real-time data, completely eliminating the need for constant manual refreshing.
Let's jump into Section 4, Bulletproof Execution with CTrade, which is essentially the engine of our system. Because let's be real, All the brilliant logic in the world means absolutely nothing if your bot fumbles the actual execution. If you've ever written procedural scripts, you already know the grueling, frustrating reality of manually populating a massive MQL trade request struct. You're constantly juggling action types, magic numbers, tickets, deviations, and if you miss even one tiny detail, the whole trade just fails. But the pro way? That involves using the standard library CTrade class. It abstracts all of that messy boilerplate code into an incredibly simple, elegant one-line command. You're literally just typing .buy or .sell, and you're done.
And the reason this CTrade abstraction is truly bulletproof is because of how tirelessly it works behind the scenes for you. Think about it. When you send a request, the broker's server might suddenly throw back a trade_retcode_requote or a trade_reject. It happens all the time. But validating the MQL trade check result and dealing with all those messy server responses, that is completely shielded from your main strategy logic. The trade engine steps up and handles all that heavy lifting, making sure your execution is as resilient and error-free as possible.
Finally, we arrive at Section 5, the CExpert Strategy Framework, which is really the absolute peak of MQL5 design.
Let's move to this next concept and see how this all builds together. We are now at the final stage of our evolutionary arc here. The CExpert base class basically acts as the master controller, or the brain, delegating tasks to strictly isolated decoupled modules. First up, you have the signal module, which evaluates your entry conditions using methods like long condition or short condition. After that, the trailing module steps in to manage risk on any open positions. And then finally, the money management module independently calculates your optimal lot size. And here's the best part. Because these are completely decoupled, you can easily swap out your trailing logic without ever having to touch a single line of your signal code. It's incredibly modular.
And this brilliantly illustrates a massive real-world benefit for the end user. By utilizing MQL5 input groups, your perfectly clean backend code actually translates directly into beautifully organized parameters right there in the strategy tester. As you can see, things like signals, trend, exit rules, and money management are all completely separated into their own distinct groups. It's amazing because your underlying code structure is directly dictating this super user-friendly, highly optimizable terminal interface.
I want to bring up a quote from the MQL5 documentation that really hits the nail on the head. It reminds us that object-oriented programming is primarily focused on data, while data and behavior are being inseparably linked. And honestly, that is exactly why we're exploring this transition today. By cleanly encapsulating our raw market data within standardized classes, and then attaching very specific, isolated behaviors directly to that data, we completely remove all the chaos of those old procedural scripts.
So, what does this all mean for you? Well, it leaves us with one final, pretty important question. The very next time you sit down to write some code, you have a choice to make. Is your next algorithm going to be a fragile, hard-to-maintain procedural script, or are you going to leverage the true power of the standard library to engineer a standardized, production-grade CExpert machine? The tools are all right there waiting for you. Thanks so much for joining me on this explainer today. Keep on engineering, and I'll see you in the next one.